Here we have a sample problem where we're asked to name a compound. When we take a look at this compound, we see right away that, we have our alternating double bonds, so we have a benzene ring in the middle. Now, the important thing with this is that the benzene ring is in the middle. So that means that the benzene ring is going to be our parent here. Everything else is just a branch off of the benzene. So let's see what we've got. Well, the nice thing here is all of the branches are the same. Each one is a 2-carbon branch, and they are evenly spaced out. So it doesn't matter which one we pick as the first one. I'm going to number them off then in this way. 1, 2, actually I'm going to go clockwise. 1, 2, 3, 4, 5, and 6. Okay, so it looks like I have 2 carbon branches, so that'll be ethyl branches on carbons 1, 3, and 5. So I'm going to start off by writing 1, 3, 5. There's 3 of them, so it's going to be triethyl, because ethyl means a 2-carbon branch. And then my parent here is benzene. So this chemical we would call 1,3,5-triethylbenzene. I've written it in different colors so you can see which parts are coming from where, but it would all be one word. Here we have another compound that we need to name. It is going to be a little bit trickier, but it's not that much more complicated than what we've already done. So what we can see in this one is that we do have another benzene group, but the stuff coming off of the benzene now branches multiple ways. So what that means is the benzene here is not actually going to be the parent. We're going to have some sort of parent made out of these other carbons. So first thing we've got to do is find the longest possible ring. So the longest possible chain is here. It's a 5-carbon chain, so we know that this is going to be pent-based. So we have a benzene ring as a branch. That means we have a phenyl. We have a pentane involved here as well. What else do we have in terms of branches? Well, we have 2 different types of branches. One of these is an ethyl branch. The other one is a methyl branch. It just has 1 carbon at its terminal vertices. So we've got a lot going on in this one, but it is actually pretty straightforward. We just need to make sure everything goes in the correct order. But in order to order that properly, we need to make sure we number everything off properly as well. Everything's kind of sticking though to the left-hand side, so it's pretty easily clear that our numbering order is going to be from left to right in this case. So our phenyl group is on carbon 1, our ethyl group is on carbon 2, and our methyl group is on carbon 3. Now we have everything we need. We just have to write it out all in alphabetical order. So in alphabetical order, first thing would be the ethyl. This will give us a 2-ethyl. Next is going to come the methyl, 3-methyl. Then the phenyl. And finally, we end off with pentane. So this would be 2-ethyl, 3-methyl, 1-phenyl pentane. And we know, because there's lots of complexity here, that the benzene ring is going to be a phenyl instead of the central parent.